By the end of this lesson, you should be able to express derived quantities as well as their units in terms of base quantities and base units. What are the students doing? Yes, it looks like they're measuring the length, the width, and the height of the classroom. What can they do with these measurements? What can we calculate from the length, width, and the height of the classroom measured by the students? What is length multiplied by width? It is area. The unit for area is meter squared. And what is length times width times height? It is volume. We can also get its unit by multiplying the units of length, width, and height. Thus, the unit for volume is cubic meter. Notice that multiplication of base quantities gives us a derived quantity. Can you express a derived quantity in base quantities? Let us recall the derived quantities that are familiar to you. Area, volume, density, momentum, power, frequency, work. Can you express a derived quantity in base quantities? Let us look at a few examples. A car speeds on a highway and travels a distance d in time t. We know that speed is distance divided by time. What is the unit for speed? The unit of speed equals unit of distance over unit of time. The unit of speed is meter per second. We have just identified the base quantities in the derived quantities. A student calculates the density of a wooden block from its volume and mass. What are the base units for density? He knows that density is mass divided by volume. Therefore, the unit for density is equals to the unit of mass divided by volume. Let's work out the base unit for density. This is equals to unit for mass divided by length times width times height, which is kilogram per cubic meter. Now, let's look at the next example. A moving car has momentum. Given that momentum is product of mass and velocity, state momentum in base units. Let's work out the base units for momentum. Therefore, The base units for momentum equals to the unit for mass times displacement divided by time. Thus, the base unit for momentum is kilogram meter per second. Given that the unit for velocity is meter per second, determine base units for acceleration. Acceleration is defined as the change in velocity over time. The unit for force is Newton. Given that force equals mass times acceleration, find the base units that is equivalent to Newton. Determine the base quantities that make up force.
Drag and drop to complete the table. Complete the worksheet. Complete the crossword puzzle.